All right, yep. So first of all, I'm shocked, absolutely shocked that you're here. My plan was, no one is here, I can go to sleep. Because although it's 8:45 here, my local time is 10:45 and I'm old enough to go to bed by 11. So that's perfect timing to go to bed. But thank you very much for coming. Really, I didn't expect to see you all here. So it's really appreciated. All right, I hope this time will be well spent and you will be at least entertained because it's a fun talk. All right, so coding fast and slow, applying Kahneman's insights to improve development practices and efficiency. So Professor Daniel Kahneman, who heard about Professor Daniel Kahneman? All right, so you all know what to expect. For the rest of you, you are in for a treat because you know what, now I know that your time here is well spent because this is an amazing individual, unfortunately passed away in March this year. Among other things, he is a Nobel Prize laureate in economics for 2002. Now, the interesting fact, not only that he won the Nobel Prize, that he is not an economist in any way, shape, or form, he is actually a behavioral psychologist. And you might ask why a behavioral psychologist wins a Nobel Prize in economics, and that's a very good question, and I'm going to explain it to you. For having integrated insights from psychological research into economic science, especially concerning human judgment and decision-making under uncertainty. What does it mean? Well, so this is how it goes. If you ever took any class about economics, high school, college, whatever, it goes like, okay, people are rational, that's why markets work, right? And we kind of know that it's true because this is how we behave. When you want to buy something and it's cheap, you will buy more of it. If it's more expensive, you'll buy less of it. It's also true for like if there is more of something, it will be cheaper. If there is less of something, it will be more expensive. It works. Well, not really. Because people are not rational, and here's 50 years of study that prove that people are not rational and they actually don't behave in the way that they're supposed to behave. And wow, that's profound, and it's probably deserve a Nobel Prize, and it's like, oh, now all our foundations are fucked up. Well, not really, because the markets still work. And the markets still work because people are rational sometimes. Enough times for markets to work, but still, those are great findings which have implementation in economics, and this is the Nobel Prize. So, 50 years of behavioral psychology studies by Daniel Kahneman and his colleagues. A lot of it is summarized in this book. It's called Thinking Fast and Slow. This is why the talk is called Coding Fast and Slow, because we'll borrow from this research and see how it applies to what we are doing. But if you want to read, if you want to learn more, if you want to read one book of Daniel Kahneman, that will be the book. I think it's 2 before his last, but the last 2 were kind of very niche and much harder to read. This is actually the book that is summarizing his research in the broadest way, and it's also very kind of popular reading. So this is a great way to learn about Daniel Kahneman. Here's an example of what we are talking about. I'm going to give you a very simple mathematical problem, and I need you to answer immediately without thinking, very fast. And people who know this will shut the fuck up. I look at 2 of you at least. A bowling ball costs $1.10 in total. The bat costs $1 more than a ball. How much does the ball cost? Fast?
5 cents.
10 cents? Some of you that said 10 cents. And obviously, this is what we want to shout first because, well, there are clues. Well, and it's obviously the wrong answer, 10 cents. Because if the ball costs 10 cents and the bat costs $1 more, the price of the bat should be $1.10, which gives us $1.20 in total, but the total is only $1 and, no, it's good. Only $1.10. So obviously the answer is 5 cents. I will explain in a second why we all, okay, so Professor Kahneman uses, when he presents those problems, he uses the phrase, if you are like most of the people, you thought this. So that's exactly that. If you are like most of the people, your answer would be 10 cents. And it's fine, we're going to explain why, and we're going to talk about how can we think differently. My name is Baruch Sadogursky. I'm at JBaruch Everywhere, a developer productivity advocate with the company called Gradle. We make very cool shirts, but also a build tool that you all know and love, asterisk, maybe, sometimes. We also do other products for developer productivity. We're going to maybe mention them because they paid for my flight. Development, started as a Java developer many years ago, went all the way to DevOps with another company that you know and love, asterisk, JFrog, and now doing developer productivity engineering, hashtag DPE, and wrote a couple of books, DevOps tools for Java developers, Liquid software. The most important slide of this talk is this. If you go to speaking.jbaruch, you are going to find there the slides, the video that are recording right now, hopefully I tapped all the right buttons, and all the links for everything. Professor Kahneman, his books, his study, all the research that we are going to mention, it's all there. To make it very easy for you to remember, it's conveniently in the bottom of every slide, together with my social, hashtag DPE, at Dev2Next. When you praise this talk, that will be good things to mention. Yeah, so why did we, if we are like most of the people, wanted to say 10 cents when it's obviously not 10 cents if we think about it for like half a minute, right? Why? Because, as Professor Kahneman puts it, we have two systems in our brain. One is called System 1, and System 1 is responsible for fast, intuitive, automatic responses. And that's exactly what we used to shout 10 cents because, and we also felt very good about it because we knew the answer immediately, although it was wrong, because it's cheap and eager to serve. Cheap is very important. We're going to get to it. The reason why it's eager because it's cheap. We're going to get to it. The second system, called conveniently System 2, is exactly the opposite. It is slow, it is analytical, it's controlled, logical, and expensive and lazy. So when I told you that that 10 cents is a wrong answer, your brain was like, okay, System 1 fucked up, let's plug in System 2, it will be expensive, but we need it to get the right answer. You did the, whatever, first grade math, and then you got to the right answer. This is what happened, and this is absolutely normal. The way it works is that System 1 goes like, hey, I recognize this pattern. There was $1.10 and then 10 cents. I know exactly the answer. The answer is $1. How cool is that? And then System 2 like, let's think about it for a second. We usually cannot really do that. Right? That's exactly the problem. The System 1 usually is out there shouting the right answer, and we are lost. All right, let's try something else. Here is a very simple problem with a bug. So let's see if you can spot the bug. This is something to actually obviously engage System 2. The lights are, it's not very bright, I know, but I hope you can see something. Probably should really do it in a light theme next time. Yeah, but I hope you can see it's not a large room. In any way, system 2, all the way, it's late, you put an effort, go for it. Tell me what's wrong there. It's pretty obvious.
If condition, the negative or condition.
Yeah, what about it?
So it will allow all the lines.
No. No, it won't. Won't allow all the lines.
Well, arc lengths cannot be equals to 1 if you pass any parameters. So I believe like that's
No, I mean, if it's not 1, then it's like an invalid argument.
Logical and over there, right? It should not be start with and
That would be an improvement, but what really the problem of having, it's like a double negative, whatever our language teacher told us not to do, but it's actually valid in logic. If you do if you do not and then or, it should kind of work. But you are very in the vicinity of the problem. You're somewhere there. All right, I don't want to kind of shame you that you forgot your basic Java. That's not the purpose of the exercise. The purpose of the exercise is to exercise your system 2 and make you a little bit tired. The problem is right here. Do you remember what this does? Why there are 2 lines and not 1? What's the difference between 2 lines and 1 line? Yeah, it's a lazy OR. What's going to happen? Because we have 2 of them, how does it work?
So if it doesn't start with 1.
if the first is true, it won't evaluate second.
Right, so what is going to happen with in our case?
It will include that slashes.
It will allow the slashes. All right, okay, so we managed, not bad, it's fine. Again, the idea was to exercise your system 2. Now, what we're going to do is you're going to shout immediately with system 2 the color of the letters. The color.
yellow, orange, red, blue, green.
All right, okay, you managed because you knew that I'm going to trick you. But if it was coming out of the blue, and if you are like most of the people, doing this exercise would be tricky. Because we usually read the word first, and system 1 is eager, so it shouts it out. Now, it became more difficult for you to discipline actually saying the color and not reading the word because of the tiring exercise with the stupid Java code that I gave you. And that's because you have mental fuel. And obviously, the end of the day really helps here. You have mental fuel, and this is how tired you get towards when you do something that requires mental fuel, and then you recharge it during the night. The beautiful thing about it that it is not only our experience or behavioral experiments, this is actually proven with physics. In your brain, you do have a fuel. Attention and capacity limits in perception a cellular metabolism account. This is a very smart research from Institute of Cognitive Neuroscience, whatever, blah, blah, blah. I have no idea what any of that means. And when I have no idea of what any of this means, I obviously go and ask ChatGPT, explain the paper, attention capacity and limited in perception, blah, 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 to me Barney style in 1 paragraph or less. So Barney style, it's a kid show with the dinosaur named Barney, and he explains stuff to kids. It's a reference from a sci-fi book. Never mind. Anyway, explain to me Barney style. Here we go. Imagine your brain is like smartphone battery that drains as you use apps. The paper says that our brain has fixed amount of energy for tasks like phone battery has limited juice. When you do something that needs a lot of focus, it's like running a power-hungry app. It uses more of your brain energy, and just like closing apps to save battery, your brain tries to save energy by paying less attention to less important stuff, which means engaging system 1 instead where it really should have used system 2. So we do have a mental fuel, right? Whatever brains and whatever, that's like the chemicals that are our battery, whatever, but cellular metabolism is our mental fuel. And it's finite energy supply. It really kind of runs out towards the end of the day. High load versus low mode. This is from this paper. Like high load and low mode sound very familiar, and it's actually exactly System 1 and System 2, according to Professor Kahneman, and that was proven independently. Professor Kahneman observed people shouting 10 cents, or whatever it was, $1, and those folks actually studied the chemistry in the brain and came to the same conclusion, which is pretty amazing and pretty sweet. So, all right, here's a question for you. Which system do we use for coding? Who thinks we use System 1? Well, who thinks we use System 2?
I think yes.
You think yes. That's probably the right answer. We'll get a little bit to what we use of System 1, but analytical control and logical is definitely used for software engineering, right? We'll get to the part of System 1 that we might use and why and when. But yeah, I mean, software engineering, when it's not like your mundane tasks of doing some boilerplate, writing getters and setters and whatever Spring Boot initializer, when you really like do important heavy stuff, it's definitely System 2, right? Okay. Keep it in mind, we'll get back to it. Okay, I need to read this name from my speaker notes. Mihai Csikszentmihalyi. There was no...
Bless you.
Yeah, huh?
I didn't get the name.
Mihai Csikszentmihalyi. Not a chance that I would remember it or recall it without reading. But yeah, this guy kind of brought the term flow to our attention. I had a book called Flow, and this is how the flow is defined. State of effortless concentration, so deep that people lose their sense of time, themselves, and their problems. Artists have it, musicians have it, and obviously software engineers have it. Who never experienced flow? None, obviously all of you did, because this is actually why we are doing that, for those precious moments. The most interesting part of this definition is the word effortless. And this is something that breaks our smartphone analogy. Because in smartphones, there is no way that a power-hungry app, which is System 2 in our software development, will do something without consuming a lot of power. In our brain, it's possible. Flow is a magical shortcut that gives you the resources of System 2 without paying the high price of using System 2. This is pretty extraordinary. Now, when you are not in the zone, when you are not in the flow, and you always have interruptions, you need to concentrate, and attention control is the opposite of flow. It's very, very expensive. Yeah, another book, another amazing professor, Gloria Mark. She studied attention for also like 15 years or something. And Gloria Mark published a book, very fortunately for all of us this year, in which we can read about the research without going into the weeds of scientific papers. It's called Attention Span, and it's really cool. Some very surprising and profound findings that will shock you as they shocked me. For example, the average person checks their email 77 times a day. You know that you check email frequently, but I'm not sure you are aware that you do it 77 times a day. On average. So if someone checks it 3 times a day, the rest of us check it more than 77. This is really scary shit. But okay, how about attention to any screen is 47 seconds? Again, you know that you kind of switch attention between screens, but 47 seconds is really amazing. And the most important one for this talk is this. It takes 25 minutes to return focus to a task after interruption. 25 minutes. Remember this number, we're going to get back to it in a very unpleasant discovery that we're going to make. Yay, more system to work. It's not getting any easier. What's wrong with this code? It's not a bug per se, it's just something really that you shouldn't do.
Well, the formatting bothers me.
Formatting sucks, but it has even more profound implications than just formatting. Double for currency, yep, you shouldn't do that. Right? You shouldn't do double for currency because two main reasons. Precision, rounding fuck up, your accounting people won't like you not a bit. And formatting is also, if it won't be those nice numbers of 115, it's going to really fuck it up. Okay, so you did that, you executed your system, exercise your system to a little bit. Let's count triangles. That's fun. How many triangles?
14.
Definitely not 4. 14 is closer, yeah.
5, 6, 7, 8, 6. It's a lot.
Come on, how is 6? Including all the outsides and the insides and...
1, 2, 3, whenever you like.
6, 12,
10,
No, more.
There should be 1, 4, 16.
Close.
8. Yeah, that's the count.
22, yeah. All right. Who fucking cares? 18 if you really want to know, but back to Java.
Yeah. Is there a question? What's the question?
What's that? There's something definitely wrong with this code.
Still the double.
Yeah, still double, but there is better, like more important things to worry about.
Tax rate isn't a percentage.
yeah, it's not divided by 100.
Yeah, is it that, right? Tax rate is not a percentage. All right, so I don't know if you noticed, but this one was much more obvious than the previous one, and previous one you collectively solved faster. Because in the middle were fucking triangles that got you out of the context, and you did a context switch, and the context switch is really, really problematic. Now, you deplete your fuel by context switching. You deplete your fuel by context switching. And you are not in the flow because of context switching. So this is a lose-lose. You need more fuel to keep your attention because you got interrupted, but you actually have less fuel because you weren't in the flow, so you waste more energy on the same task. All right, more studies. Now this one is really something different. This is like a mind-boggling study. Characterizing and predicting mental fatigue during programming tasks. Are you sitting? You ready? Hold to your hats. This is going to blow your mind. Developers are cutting corners on the quality where they're fatigued.
No.
I swear to God, honest to God, research. Like peer-reviewed in magazines.
Well, you do have to prove common sense.
Yeah, so yes. Now, obviously, I mean, I have a link here to acm.org, which is like a scientific library of scientific papers. It's there. And you have it, you know where to find it if you want to show it to your colleagues on how people spend their time. So anyway, yes. Now, obviously, this is fine. And you would expect that you're just know that you are tired and you start cutting corners and then you just stop working, right? Wrong. The problem is we don't know where to quit. And the proof is in Professor Kahneman's study. Now, he made a study observing parole judges in Israel, like whatever, 30 years ago, 50 years ago. And so how does it work? The parole judges are by default refusing parole because like giving someone a parole, it's like a big decision and the default is deny. Now, what he discovered, and this is pretty amazing, is that when judges were hungry or tired, they gave fewer paroles. Fewer. They defaulted to denial. Now, this is very scary because obviously they didn't do it on purpose, right? They're judges, they're about justice, and they obviously didn't realize that their behavior changed when they were tired. And the reason is that granting parole requires system 2 thinking, and judges were unaware when they switched to system 1. And if those people are unaware when they switch to system 1, when they do work that they obviously know the importance and how decision, like there are people's fate on the line, right? It's like getting out of jail, it's a huge deal. It's much more important than whatever buttons we colored this week, right? No? Yep. All right. So obviously, you're not sure. Yeah, so obviously, if they are not aware, obviously we are not aware when we switch to system 1. And then we start coding with system 1. Now, what we do when we code on system 1, we produce an okay code. I mean, it works, but it's definitely not great. Now, Alex here voted for coding with system 1 when we asked if we need system 1 on system 2. And, well, exactly, because you save system 2 for important stuff. But he had a point. And the point is that sometimes we just write code which is intuitive, which is like we write code without thinking about it, and it's fine. And I want to talk a little bit about intuition. Because, yeah, that was Alex when I said system 2. So, because intuitive. All right, so what's the story with intuition? Rapid pattern recognition and associative memory. Those are the traits of system 1. And it looks like it has something to do with our work because of a lot of the time this is how we do stuff and it's fine. Now, there is a caveat. We can definitely learn how to code on system 1 without giving it much thought. But intuition, according to Professor Kahneman, is executing skilled responses and generate skilled intuitions after adequate training. This looks familiar to whoever read this wonderful book called Outliers by Malcolm Gladwell. This is the book that popularized the 10,000 hours thingy. The 10,000 hours of practice makes it perfect, and if we code enough, we can code with system 1 as it was system 2. We are familiar with this phenomenon from our daily life. Recall your first driving lessons. System 2 all the way, like to the max. How are you driving today? Absolutely system 1. You can do like you do it without thinking, and if you are like other people, me for example, you might find yourself in the parking lot of your office on a weekend because system 1. You drove there without thinking because you did it for 10,000 hours or more. So why not coding with system 1? We definitely do it for 10,000 hours or more, But 10,000 hours works for some activities like driving, golf, tennis, music playing, and safety drills for firefighters. I'm going to talk about that in a second, but first, I want to ask you if you see a pattern between all those.
Physical activities? Yes.
Physical activities, yeah, but a lot of that is physical activities, but there is muscle memory. What does it mean, muscle? How do we gain this muscle memory?
Executing again and again.
Repetition, but also not only feedback. Very short and very reliable feedback loop. We do something wrong when we learn how to golf. Whatever the term is, putting, driving poorly, and we see exactly that the ball goes to the wrong direction. Now, this is also true for firefighters, and this is an example from Daniel Kahneman's book. The example was, and this is how he kind of discovered what intuition is and how it's related to System 1. He interviewed a firefighter, well, the team lead, that managed to call off his firefighter team out of a burning house seconds before the floor collapsed. And when he was asked, how did you know to do that? He was like, I have no idea. I had an intuition. I just knew that it needs to be done. And Professor Kahneman, who didn't believe in intuition and like in the 10,000 hours as a broad true statement, started to investigate why it happened. And it turns out that the firefighter knew that the floor is going to collapse because he recognized that the sound of the fire changed. Because the fire got to the basement where the composition of oxygen was different. And he knew to recognize this sound, and he knew that the next step, the floor will collapse. And the reason he knew that, because he was very experienced and practiced a lot. So this is very true for those activities that you can really convert from System 2 to System 1 by pattern recognition after training, right? So that's our I recognize this pattern, and well, wait, let's think about it. So pattern recognition is definitely System 1. Now, does 10,000 hours, now you know its limitations of this rule, does it apply for software development? To an extent. To an extent. You probably can write getters and setters without thinking about it.
Does it automatically?
Well,
I don't know about you, but my IDE does that.
thank you for this shout out, of course. You know what I mean, right? Intuitive is definitely out there helping us developing, but it's the OK code. It's not what really stands out when we are talking about great code. It's OK code. It's not great, not terrible. Which sucks less? Both of them suck. Which sucks less? Bad code or OK code? Who thinks that OK code sucks less? Well, because it works. Yeah. Who thinks bad code sucks less? Yep. I think that bad code sucks less because it's just bad and easily recognizable as bad. And then you just don't do it. The problem with OK code that it flies under the radar. It looks OK to us. Why?
Because it's okay.
Because we are on System 1. We are tired. We're just throw it, it's OK, it's fine. It flies under the radar and looks OK to our PI reviewers. Why?
Because they are tired and hungry.
They might not be, but they definitely don't want to spare their fuel on someone else's code. So they'll be like, looks good to me, or some stupid reformatting to pretend that they actually look at it. But they kind of skimmed over it. Their System 2 fuel is reserved for their own code, not yours. And it looks OK to pipelines. Because what you can program in the algorithm is by definition pattern recognition, which is system 1. And this is how we end up with OK product. Now, I think that most of the software that we encounter today is OK software. Think about really good products. IntelliJ used to be.
Ouch.
Netflix,
Still good?
still good. Used to be. Has bugs. I didn't see much bugs. I mean, content is a different story. But in terms of software, I think they're still good. But what else? Like Google? Nah, definitely not. What? Like whatever x.com thingy? Obviously not. What else? What is like really good product? Not much. Most of the software that we see is OK software. It didn't used to be, but we also had much more. In general, as humanity, we had much more system to fuel before all the attention span debacle. Right? So most of us have much less system to fuel. Most of us do much more on system 1. Most of us end up with writing OK code, and all of us end up with OK product. So what can we do to fight this gloomy picture that I draw here? Invest in fuel-saving techniques. And the goal is to have enough fuel, maybe not to last all day, but definitely to have it when we need it all day. How do we do that? Time management is, well, as you know, very important. Stuff like time blocking, Pomodoro technique. Who knows about Pomodoro technique? All of you, obviously, who uses it. No one. Oh, 2 people. Thank you. Now, Pomodoro technique is basically batches of whatever 25 minutes of work with 5 minutes of rest. By the way, why 25 minutes? Anyone knows?
Average attention span.
Average attention span, well, it was 25 minutes. Good that you remember. No, but we'll get back to those 25 as well. It's because the guy who invented that and used the kitchen timer in the shape of Pomodoro, the timer was for 25 minutes. So this is how it's 25 minutes. It obviously doesn't have to be. It can be whatever, 45, whatever works. And this is actually, you can say, well, but this is like, you context switching. You just told that it's bad. Well, the 25 is the minimum, right? If you are in the zone, if you are in the flow, you are not stopping after 25, even if your Pomodoro clock goes off. But if you are not in the zone and after 10 minutes you think about checking your email, this is where it's actually helpful to not do that because of your timer. So yeah, task batching, just combining tasks, similar tasks together. Now, shout out for a really great software this time. It's called Reclaim AI, and I use it personally and recommend it to everybody. It does basically all that. It blocks time. But blocking time is not enough. You can say, you know what, fuck it, I'm going to block all my calendar. No one touches me, no meetings. I just gonna code all day. This is not gonna happen. If you block all your time, it's equivalent of not blocking time at all, because people do need access to you, and if they cannot find access during the times that you decided, they will find time during the time that they decided, ended up in you have no block time at all. So Reclaim allows you to block time, batch tasks, but also allow access. They do it in a smart way with movable blocks of time. So let's say, you know what, I need 3 hours of just writing code every day. But those 3 hours not necessarily have to be during a certain time. When your boss wants to schedule time with you, they will see a lot of time is available. And if they block some of your time, those 3 hours will be shifted to when it's possible. And when you have less and less of those openings, those 3 hours will become more rigid and rigid until they will be like, those are the only 3 hours available, and they are blocked. They also do tons of other amazing stuff like habits and working with tasks and all this kind of stuff. And I just really recommend this tool. I need to ask them about referrals, but I keep forgetting. So
Did you create a task for it?
thank you. All right. Mindfulness and cognitive practices, meditation. Now, meditation is a funny thing. I told you that the analogy with the smartphones kind of breaks a little bit on the edges of our model. This is another exception because our battery in our phones, you cannot extend it by exercising. Your mental fuel capacity, you actually can. And meditation is the way to extend your mental fuel capacity, as weird as it sounds. Really works. Reflective practices, that's kind of the same thing. Single tasking, again. Workspace and interaction management. Well, now with everybody back to office, you know what to do. Noise cancellation headphones, not having open space and cubicles, and all this kind of stuff. Notification management, again, you know what to do. Just kill the bastard. They're not good for anything. Prioritization techniques, spoke about that a little bit. Decide on what's important, put it on reclaim to make sure that you actually have time to do that. Physical and mental well-being, well, go to gym. Victor is not here, but go to gym. He's in the gym, of course. Breaks and downtime. Okay, now this is important. Speaking about breaking our analogy with the smartphones again. In our brain, we have a secret stash of mental fuel that is not available for us on a normal kind of operation, but we can unlock it by having a nap. Now, if you took a nap, you probably hate it because you wake up groggy and it's actually worse than it used to be. But there is a solution. That's like you taking a nap and getting to the resource. There is a solution. And the solution is discovered by another doctor, Dr. Sarah Mendrick, and she wrote a couple of very important books about sleep in general that I would really recommend. If you're still under the impression that sleep is optional, you can replace it with coffee, you will sleep when you are old, and all this crap and bullshit. Well, none of that is true, and just read those books. She talks about it a lot. Speaking about nap, one of the techniques that she came up and that was popularized by another great author that I forget, that doesn't matter,
The Necatino.
Yeah, all the credit goes to Dr. Sarah, caffeine nap. The way you do it is you drink caffeine and you just go to a dark, cold and quiet room and you set alarm to 20 minutes and you wake up perfect. You have mental fuel reserves that were tapped and you're not groggy and you are in your best shape. And the reason why it works because it takes 20 minutes to your caffeine to hit your brain. So by the time you need to wake up, the caffeine just arrived and you're like, whoa, you feel great. I practice it a lot and I definitely recommend you doing the same. It sounds weird, but it really works. And if you don't drink coffee, it can be any other caffeine resource, tea or whatever. And if you don't drink caffeine, you should really do something with your life priorities. It's just weird. It's just weird. I mean, why? All right. So that was very nice. A lot of useful practices, but we can also engineer some of them. We can use engineering approach to improve our developer productivity and ease on those context switches and what's not. And developer productivity engineering, in essence, is just a bunch of practices that you need to think about both on individuals and as an organization. For example, eliminate toil. If there are processes which are there but not helping you get your work done, those processes are toil and should be fought and eliminated. collaborate through effective tooling. And here I start to talk a little bit about Gradle, but just a little bit. So think about your build is failing, and you suspect that your colleague might be at fault. What do? You probably take the entire build log, which is like exceptions, hundreds of exceptions in the stack trace, and just shove it to this colleague through Slack. Tell me what's wrong. What it's going to do to your colleague, it's probably going to kill their productivity for 25 minutes at least, because this is how long it will take them to get back to what they're doing after they try to figure out the mess. If you could just send them the exact pointer of what went wrong, just to the line or in the test that was failed, that would be much more effective, wouldn't be? And this is what I'm talking about, effective tooling. Prioritize automation, eliminate bottlenecks. Those are a couple of DevOps tenets that are very relevant to our productivity as well. Observability and proactive improvement. Outcomes over output. Build log is output. One line why the build failed is outcome. And dedicated organizational mindset. The best organizations out there that still produce great software, Netflix, for example, invest tons in developer productivity engineering on the organizational level. And this is why, one of the reasons, they are still providing great software and not okay software. It works. All right. The first one, which I showed the last because we're going to talk a little bit about it, is foster faster feedback. It's late. Foster faster feedback is critical for our ability to use System 2. How does normal feedback efficiency look for developers? Well, we have our IDE, we write our code, and our IntelliJ will mark if we wrote something wrong as we type it. Sub-second feedback. And this is absolutely awesome. And then we finished writing whatever we're writing, and we run our local build to verify on the next level that what we did is good. It might run some tests and basically do some verification. And we expect it to take seconds. The farther we go, we do pull request and it gets into our CI. Then we're talking about minutes and maybe hours. Not hours, but closer to tens of minutes on what's not. And then another feedback, which is our production, which is very important feedback. I guess we all agree it might take like hours or days or whatever, how frequently we commit. So there is a pattern here, and it's a reverse dependency on distance from developers. The more to the right side we go, the slower our feedback gets, right? Looks good, all agree. Now, this is the ideal curve. The reality is not that great, mostly because of build. We want the build to last seconds, but in reality, whose build is less than a minute? No. How about 5 minutes? 5 minutes, some 10 minutes. I guess most of you will be like 5 minutes.
Under 10.
5 minutes neighborhood. Now, I have very bad news for you. If your build is slower than just really a couple of minutes, your build is how long?
25 minutes.
25 minutes. Because you will wait for a build that takes a minute in the flow. Maybe 2 minutes. If it's longer than 2 minutes, what are you going to do? You're going to multitask, which basically means read Twitter, answer emails, and it will take you 25 minutes to get back to the task. And no one cares that the build ended 20 minutes ago. Your build is now 25 minutes. It sucks. There are two types of feedback. The one that is asynchronous and synchronous. Asynchronous is the one that you don't wait for it, like CI, CD, or production. You never wait for it. It's very disruptive when it's broken. but you never wait for it. The synchronous one, like build, you'll wait for it in flow, but when it's long, you will be pissed off and you start multitasking. Now, the reason why we do local build is we don't want to wait for CI. We do local build. It gives us reasonable assumption that our code will pass CI, and then we throw it to CI, start doing other things. Chances are it will be okay. If not, it will be distracting, but we did the local build, so we're pretty sure that it should be okay. Now, the line between synchronous and asynchronous is the commit time. Faster feedback, there is a typo there that's very confusing, saves mental fuel. How does it save mental fuel? Speeding up local builds minimizes context switch, because you will wait for the build and flow, and then you have less context switch, which saves mental fuel, and then you run on system 2 longer, or at least you have the mental fuel when you need it. So we really need to invest in faster builds. How can we engineer less context switches? First of all, we need to know that a problem exists, right? A lot of organizations that we ask the management how their local build times are, they have no idea, especially if the people working remotely. They have really no idea. Now, the developers don't know how to benchmark their build. Is 5 minutes is fast or it is slow? Maybe when I moved to work remotely, my build now is 15 minutes, but I don't even know that the people in the office actually the build is 2 minutes. I have no idea, so I think that 15 is fine. Once we measured, we can start optimizing. And there are basically a couple of things that we can do. We can avoid building and testing what didn't change. Some of the build tools, most of the build tools, do some of it out of the box. This is your incremental build. It will analyze the modules and the dependency between them, and if something didn't change, or we are not dependent on something that it changed, we will build less and test less. But not all the tools do it, and not all the tools do it efficiently. The other one is speed up what cannot be avoided. And here I will give you an example. This laptop, I have a build, demo build for it. It builds in 2 minutes. Doesn't do much, but the build is 2 minutes. Now I change one line of configuration of my build tool, and it starts building in 6 seconds instead of 2 minutes. What is it? Skip test, yeah, that's a good idea, but no. Not cache. Cache is more not building what didn't change.
Parallelize things?
Parallelize things, right? This, whatever course it has, when I say just use all of it, it improves the build 20 times. 20 times faster. I didn't do anything. It's the same build. Flaky tests. A very disruptive thing. Again, how many teams know that they have flaky tests? For a lot of people, it's just the reality that they deal with. Well, we'll just run this test 3 times. We know that it might fail. And if it's last in the suite, how disruptive is it that it's actually not a real fail? And then degradations. Because everything degrading, test is not exception, we really need to watch it. What we can do today for free to engineer less context switches. Parallel local, I just gave you an example of how amazing the savings are. Local caching, absolutely free with both Gradle and Maven. Implement a little bit better in Gradle, but you know what? Do something better than nothing. Just use caching. Maven 4 has experimental caching built in. If you start using Maven 4, which looks exactly like Maven 3. So there is no risks in upgrading, as opposite to Gradle, which every upgrade is an adventure and you have no idea what it will break. Maven, very safe upgrade, and you will get free local caching, which you really, really should do. With Gradle, local caching been there from day one. You just need to start using it. Remote caching, small asterisk right there. You will need, if you want to share your cache results within your team, it's very, very effective. Now, not only you not build what wasn't changed, your teammates won't build what wasn't changed and was already built by you. All you need is a HTTP node that will serve as the remote cache, and this is the asterisk there. You will have some time working on, like, maintaining it, or you can just buy Gradle velocity. It comes with the product. Build scans. This is about analyzing your build, how slow, fast it is, using effective collaboration, because build scans allow you to send this link to the entire, to the exact failure line that we spoke about, and a lot of other tenants that are all there. Observability, bottlenecks, a lot of that you can do out of absolutely free service from Gradle, the Gradle build scans. And you can win prizes by trying our speed challenge, which basically, hey, do you have a project that we can try and speed up? And we will give you awesome swag, again, for trying it out. What your company should really pay for? First of all the books, because they're really worth reading for you and for your team, so let them buy the books. Top development hardware, and you know why. Because this is how you make your build faster, 20 times faster, with zero investment in the build itself. Just because you have hardware that you utilize to its fullest. The Velocity, that's the Gradle Velocity tool that implements all the tenets of developer productivity engineering. Spoke enough, the rest is right there. That's all. So Gradle and Maven Speed Challenge, the one that you can win prizes and try it for free. Be developer productivity engineering agent of change in your organization. I know that you are convinced now how important it is. Take it to your colleagues, take it to your management, speak about it, shout about it. You will make everybody's life better by doing that. You also help your career, because Netflix is hiring in developer productivity engineering team, just saying. DP handbook, all what I said and more in the form of another book. DP Summit videos last week we had 2024 DP Summit in San Francisco. The keynotes were streamed live, so they're already out there. The rest of the videos are coming very shortly. There is tons of materials from Meta, Uber, Spotify, Netflix, banks, Capital One, and Apple, and who's not. All of them are speaking about how they implement developer productivity engineering. Yep, that's the one. And yeah, watch the keynotes. And with that, thank you very much. I guess there is no more talks, so we can stay here and talk about like whatever you want to talk about until whenever, if you have any questions, or we can just go to sleep or drink or whatever. Yes. Yeah, there is a bar, so we're not going to sleep. Yes.
Question about napkin. I'm one of those people that have tried napkin and
Yeah.
I'm groggy.
Yeah.
The truth is that I'm sleep deprived, so does napkin not work if you're already sleep deprived?
That's a good question, and the answer is I have no idea. But probably the books about sleep might give you an answer. What I do know is that I'm very groggy after a regular nap, and I hated it. And the caffeine nap really works magically. You really wake up after 20 minutes like you slept for 4 hours. It's really that good. That's my experience, at least.
And there's another book, Why We Sleep.
Yeah, Why We Sleep is also a great book, yes.
I'm just halfway through every time I sleep when I read it. So.
It works. So it basically works. Yeah, nice. Yeah, there are a lot of interesting stuff to make you sleep better. There is this AI-generated white noise slash music slash sounds called Endel. They have a lot of AI noise for different situations like concentrating or relaxing or exercising, but also sleeping. I guess it helps. They claim it helps scientifically. I don't know, but yeah.
Even if it's placebo, sometimes placebo helps.
Who cares? As long as you sleep better, that's what matters.
If it works for me because I believe in it, sure.
Absolutely. Yeah, that works. So yeah, and speaking about great tools for developer productivity engineering, definitely IDE helps, of course. And also tons of utilities from Netflix help. That's also true. They do a lot of good stuff for developer productivity engineering. So yeah. All right, should we go and drink / sleep? All right, thank you very much. Okay, I'm going to upload the video tomorrow. So tomorrow go to speaking.jbaruch and share the awesomeness.